Howdy and welcome to 7.4 Part 3. Today's kind of closing out 7.4. What we're going to do is go ahead and graph today. Hopefully, if I do my job right, you'll see some connections between all the inverse stuff that we've talked about, as well as the parent-child stuff. Personally, I think that graphing logs at this point of the game you're going to find is kind of nice. We're still going to do parent-child. We're still going to do opposite x, same y. The big thing that's going to happen this time is really the difference between exponents and logs. As I've said all along, exponents and logs are inverses of each other. We've already graphed exponential functions. The graph of y equals 2 to the x, that is just a straight up exponential function. If we were to make a graph of x and y, it's pretty easy. For example, we use 0, 1, and 2 there. We would get the coordinates 2 to the 0, which is anything to the 0, exponent is 1, 2 to the 1, which is 2, and then 2 squared, which is 4. So in blue, y equals 2 to the x, you guys have seen before, has a coordinate 0, 1, has a coordinate 1, 2. I'm going fast on this because this is a review idea. We'd sketch the graph of y equals 2 to the x. I'm going to remind you of some things about y equals 2 to the x. Exponential graphs have horizontal asymptotes. Again, my graph of y equals 2 to the x would look something like that. When we close out, this is something that we did at the start of this week. Our domain, x could be anything we wanted it to be. It was all real numbers. And our range, in this case, y had to be bigger than 0. We had a range restriction. We did not have a domain restriction. Now, I want to look at the graph of logs. Logs are inverses of exponents. Inverses, it means all we do is flip-flop the x's and y's. So that means what was once x is now a y. What was once a y is now an x. So my inverse, or y equals log 2 of x, will have the coordinates 1, 0, will have the coordinates 2, 1, and will have the coordinates 4, 2 because of the inverse properties. Let's look at that. 1, 0, 2, 1, and 4, 2. We have a graph that looks something like this. I will remind you guys now of a couple other things that I've talked about before. An inverse is a reflection of that function across the line y equals x. In fact, if we folded the blue line across that, burgundy line, then we would have the graph of the red. A reflection across the line y equals x are inverse functions. So that idea makes sense. This next idea should also make sense to you. When I had the y equals 2 to the x, I had this horizontal asymptote. Oops, don't want to move those things around. Sorry about that. I had that horizontal asymptote. Now, since I'm talking about an inverse function, can't I rotate this? Oh, that didn't work. Flip it up, down. That didn't work either. So I want to take this function. I want to take this asymptote. And when it was a horizontal asymptote, it is now going to be a vertical asymptote for my log functions. That was yesterday's secret word. You should see now why we've gone from an exponential function with a range restriction, and now we're going to have a logarithmic function, which is the inverse of the exponent. My vertical asymptote became a horizontal asymptote. So now what was a range restriction before will be a domain restriction now. Before, my domain was all real numbers. My range now will be all real numbers. My range was restricted for exponents. My domain will be restricted now for logs. X is now greater than 0. And that matches. If we're looking at the graph of the log, take away the right one here. If I'm only looking at my red graph, which is the log, you should see that I have a vertical asymptote and my domain is restricted. X will only be positive numbers in this case. And my y values is going to be all real numbers once again. Okay? So graphs of logs will have vertical asymptotes. Graphs of logs will have domain restrictions. Okay? What I'm going to show you today in terms of parent-child, I'll show you how to graph logs correctly. I just want to see you guys see that big connection between exponents and logs and see that they are actually inverses. Which was once x becomes y, which is y becomes x. If I have a range restriction for exponents, I have a domain restriction for logs. Here's our first example. Y equals the log base 3 of x. Honestly, I think your parent functions are the easiest for logs. These are the absolute easiest parent functions we're going to have. And your parent function will change. In this problem, obviously, it's just a parent function. We're looking at the log 3 of x. The values you will pick for x, will always be 1, and then whatever your base is. Okay, the values you pick for x will always be 1, and then whatever the base is. You only need 2 coordinates to graph logs. Again, the x coordinates will be 1, and then whatever your base is. And now I want to look at what our outputs are. Once again, we're graphing y equals the log base 3 of x. This is a parent function. We'll translate in a second, but I want to get this basically down first. So now I want to look at it this way. Log base 3 of 1. That's what I want to know the output of. I already wrote the answer. But I want to know what the output is of log base 3 of 1. The easy way to see that is saying log base 3 of 3 to the 0. By the way, isn't 3 to the 0 just 1? And we've done this work the last couple of days, rewriting to match the bases up. So the log base 3 of 3 to the 0 is just going to be what? That answer should be 0. There's my identity, and my answer is 0. Once again, log base 3 of 1 is 0. Log base, and again, this is another thing we write, log base anything of 1 will always simplify to 0. It's an identity. Log base anything of 1 is 0, which is why we're using that as our parent function always. So if I input 1 into that function, my output's 0. Let's look at this one. Log base 3 of 3 is what it's asking for. Again, if I plug 3 in for x, that's a log base 3 of 3. Mr. Wood, you've told me all along that's just a 1. I know. That output is just a 1. So that's it for our parent function. That's all we have to do. We're using very simple truths for logs and applying it to our graph. In other words, for your parent function, these coordinates that I have listed there, those 3 coordinates, 1, 0, and 1, those will always be those coordinates. The only thing that will change, and that's why I said the base, is that. Okay? Again, log base b of b to the 1 simplifies to 1. That's what we're using. We're using that for that one, and we're using that for that one. Plot them. We've got the coordinate 1, 0. And we've got the coordinate 3, 1. We will now have a vertical asymptote. We'll have a vertical asymptote because we're graphing logs. Connect the dots. That's our graph. That's all we have to do. Domain and range. We have domain restrictions now. We have a vertical asymptote. X is greater than 0, and y is all real numbers. Y will go down to negative infinity and up to positive infinity. Again, domain, x is greater than 0. Range, y is, equals all real numbers. That's it. Checkpoint coming up. You guys. Oh, me. I'm giving you guys another problem. You're going to have a checkpoint next. I'll do another parent function for you. Once again, log. Y equals log base 1/2 of x. I'll give you guys a second to copy that down again. Y equals log base 1/2 of x. This is a parent function, no translations. Realize we'll have that vertical asymptote. We'll have to do domain and range again in a second. Parent function, as I said, you're always going to use these values. It's going to be 1, and then whatever the base is. This is the base 1/2. You'll use that. The outputs will always be 0 and 1. That's your parent function. Notice, 3 of the 4 values stay the same. 3 of the 4 values stay the same. Graph the coordinate 1, 0. Graph the coordinate 1/2, 1. 1/2, 1. Did I do something wrong here? Oops. What did I do? Did I do something? No, I'm good. We're good. 1/2, 1. 1/2, and 1 is there. There's our asymptote. And we will connect the dots. Once again, domain is now restricted and range is free. So what we got free range. So what I did there? Y is equal to all real numbers, and x, once again, is greater than 0. Okay? That's it. It's graphing logs, parent function. As I said, I think these are the easiest parent functions we have. Match the bases up, and you're good to go. Now it's your guys' checkpoint. Y equals log base 4 of x. Go ahead and pause the video right now. That's what I want you to do. Pause the video. Get that graph. When you're ready to roll, go ahead and unpause. We'll go to the next problem. Okay. Should have done that. Should have been pretty easy. 2 points, domain and range, get it graphed. Mr. Wood, this is so easy, I'd like to do something harder. Okay, here you go. Y equals log base 6 of x plus 4 minus 2. That looks a lot harder. Really? It's not. Same game. Parent-child. It seems like almost every time we graph, it's a parent-child nowadays, Mr. Wood. I know. In fact, I told you guys that like 2 months ago. All right, log base 6 of x plus 4 minus 2. I have a hunch we're going to do, I don't know, opposite x, same y. Probably. Start with your parent function. Match your base up. 1 and 6. Outputs are 0 and 1. Parent function's done. Make a child. Opposite x. Opposite x for every x value. Same y. X value is 1 minus 4 is negative 3. 6 minus 4 is positive 2. Y values, 0 minus 2, negative 2. 1 minus 2, negative 1. Plot your points. Negative 3, negative 2. Positive 2, negative 1. Okay? At this point, we need to install, or we need to put in, a vertical asymptote. The trick or the question is now, where on this graph do I put the vertical asymptote? And I'll give you a second to try to analyze that question before I give you the answer. Where do you think that the vertical asymptote will be, since I now have, here's your hint, a domain restriction, when before on an exponent I had a range restriction with a horizontal asymptote? So my vertical asymptote, which will have a domain restriction, should be located where? If you thought that your domain restriction in this case is opposite x, because we're talking about domain restrictions, give yourself a pat on the back because you are correct. Our vertical asymptote will be dictated by our change in x. So our vertical asymptote will be at -4. Again, logs have vertical asymptotes. Exponents have horizontal asymptotes. Connect the dots and play doctor. Domain and range. Our domain is now restricted. X must be greater than -4. And y can be anything in the world. All real numbers. Mr. Wood, it almost makes sense. Inverses. If I have a range restriction for my exponents, I have the domain restriction for my logs. You've been talking about it. Logs and exponents are inverses of each other. They flip-flop the x and y's. I know. That's what I've been telling you all along. They go hand in hand. They undo each other. We've been working really hard on that. Starting tomorrow, we're going to work at solving problems. We've already flirted with all that. Mr. Wood, this is pretty easy. Yeah, but I told you you'd be graphing logs really easily. 3 weeks ago, you guys would have looked at me like I'm crazy. But you can do it now. Just remember what the question's asking. Think critically. Logs, what do I know about logs? Exponents, what do I know about exponents? Logs have domain restrictions. Exponents have range restrictions. You guys, that checkpoint, give it a go. Y equals log base 2 of x minus 3 plus 1. Pause the video. Get it graphed. Unpause the video when you're ready to move on. Don't forget to play doctor on this one. Domain and range. Okay, hopefully you unpause the video. We are just about done here. Actually, this one's turning out to be a little bit quicker than I thought. I'm not going to do a word problem. We will actually look at graphs word problem-wise in class. I'm going to save that for class. I'd rather you guys be real successful in graphing the basics here so that we can look at the graphs a little bit more depth in the classroom. So there we go. I'm going to do one more example real quick. Make sure you guys get this down. In fact, this might help you if you were a little blurry on that last one. You might go back and fix that checkpoint if you need to. Hopefully this clarifies if you're still kind of in the dark about this. We're looking at y equals log base 3 of x minus 5 plus 4. Again, log base 3 of x minus 5 plus 4. Parent function, match the base. We've got 1, 3. Our outputs are always 0 and 1. Like I said, parent function for logs, 3 of those numbers stay the same always. The 4th number, which is this one right here, will change depending on what the base is of the log. Got the parent, make a child. And opposite x plus 5, same y, plus 4. 1 plus 5, 6. 3 plus 5 is 8. Changes in y, 0 plus 4 is 4. 1 plus 4 is 5. Watch your points. 6, 4, 6, 4, 8, 5. I need to get a new graph. I'll just scoot this one over and sketch it. There we go. Oh, there we go. 6, 4, and 8, 5. 6, 4, and 8, 5, 7, 8, and 5 is going to be up there. Don't forget your vertical asymptote. Your vertical asymptote will be at opposite x. That's the big change again. We have domain restrictions. It's opposite x. It'll be at positive 5. It'll be at positive 5. Move that over just a little bit. There we go. And sketch it. And play doctor. We don't have any restriction on our range. That's all real numbers. Our domain is now restricted. X must be greater than 5. Okay? X must be greater than 5. That's it for graphing. You guys got a checkpoint coming up here. Let's see. I do need to give you guys a password. I forgot to give you guys a password today. Let's see. Today's password is going to be superfragilocalisticexpialidocious. You guys have fun trying to spell that one. Again, today's password is superfragilocalisticexpialidocious. And there's your last checkpoint. That's your third one. Get them graphed again. What I want, and you might have to look back in old notes to get this graph. You should definitely be able to graph the top one. Y equals log base 3 of x minus 2 plus 1. That should be easy for you. You might need to go back in your notes to remember how to graph y equals 3 to the x minus 1 plus 2. What I want you to do is graph both of those on the same axes. Okay, graph both of those on the same axes, and it's not listed here, but do give me the domain and range on those. Okay? All right, get those done. I'll see you guys in class tomorrow, and we'll be ready to rock and roll.